So we're doing trig functions, okay? So here we go. The first one we got is sine, right? S-I-N-E. Sine, cosine, and tangent. We normally see it as S-I-N, right? Okay, so we've got sine, we've got cosine, we've got tangent. Okay, those are ones that we have. Now, there's a relationship for these functions. There's a relationship with the angle of this and the sides. All right, so how many of y'all remember this? Sakatola. How many of y'all remember Sakatola? Y'all remember Sakatola? Sakatola? Yeah, Sakatola. Sokatola? Saka, Soka, I don't know. All right, ready? Right? What do you have? A what? Okay. All right, so Sakatoa, sine, cosine, tangent. What you have, and you'll basically see it like this. The sine of theta equals opposite over hypotenuse, right? Okay, so don't leave anything to be of question. And then we've got at least cosine of theta equals adjacent over hypotenuse, right? And then last one would be what? Tangent, which would be what? Opposite over who? Good. Now, what does it mean to be adjacent and opposite? Opposite and adjacent from who? The hypotenuse? Not the right angle. Not the hypotenuse. What does it mean to be opposite or adjacent to? The angle, theta. Right? That angle could be given, right? If you're referencing an angle in a trig function, that's great. But you could also be solving, be given two sides, and be solving for that particular angle, right? So trig opened up a whole plethora of avenues for finding out stuff that we normally haven't been able to find stuff out for right triangles, right? I mean, before this, we only had Pythagorean theorem, right? Good old Pythagoras. So this was revolutionary in its time. Okay? Now, the reason why it's revolutionary is this. Okay. Guys, we can also do their inverses, right? Now, their inverses are this. So if I go, the inverse of sine would be what? That would be the cosecant, right? The cosecant of theta would be what? What would it be? It'd be the inverse of sine. What's the inverse be? This is basically one over that, right? Which would be hypotenuse over who? No. Opposite. Cosecant is the inverse of sine. Secant is the one for cosine. It's not co and co. It's everyone has one. So SEC. See? That's so correct. That's why we left football. Anyway. And then we've got what? Hypotenuse over who? Adjacent. What do you think the inverse of the tangent is? What is it? Yeah, it's cotangent, right? Cot, right? And it should be called a theta, right? Equals what? Adjacent over opposite. So it's the inverse of it. It's flipped, right? So you could also see, let me make sure y'all get that copy. You're going to also see that it can be written as in different ways. But anyway, we'll talk about these for right now. That's where. That's SEC. SEC, baby. The SEC. Ask Notre Dame after Saturday night. Who that is? Who that? SEC, baby. All right, y'all ready?
Yes.
Yeah, you love this. Okay, so first thing. We're going to, whoa, I didn't grab this, did I? I need you to find the secant of this particular triangle. Now, secant of the particular triangle. Let's see what you can do. Find the value. I'll give you a minute. No, I'll give you 30 seconds. That's really all you need. Got it. What is the relationship for secant? It's the opposite of who? Who's the inverse of? Who? Cosine. Cosine came a hopping, so it would be what? Hypotenuse over who? Yeah, adjacent, not opposite. So, guys, here's theta. This would be the adjacent. The 23 would be who? Hypotenuse. So, guys, 23 over who? 17. Okay. So we're just setting up that ratio. Now, we could find what the angle is. Right? We could find out what the angle is if you basically you do that in the calculator. You have that? Okay. See if you could figure that out by using just they're really not, they're more reciprocal relationships. Let's see if you can do that. It won't be that hard. Yeah. Yeah, SEC, inverse. I'm just curious, see what you can do. Okay. It gave you domain error, right? When we look at the graphs on these, we'll understand why it's a domain error. When you have a domain error, what does that really mean? When it says domain. That it does not what? Exist, right? Yeah? So when we look at these, which we will look at the secant, cosecant, and cotangent graphs, so that you are familiar with asymptotes, where they exist or they don't exist, and stuff like that. So, and if you remind me, we'll come back in and do this one. Let's look at let's get one that's, go tangent. Go this one. Number 3. Give me 30 seconds. You should have this. Look, tangent is what? Opposite over who? Our alley, right? Adjacent. So here's theta. This one is side. This is adjacent, and this is what? Uh-huh. I thought you so there.
Yeah, that's what it does. You just labeled it adjacent.
Ooh. Ah, yes, I did, didn't I? No, go back here. Spook. Spook. All right. Where would be? Okay. What would we need to do first? Ah, good. Good. So c squared equals a squared plus what? B squared, right? Could you, let me ask you this. Could you use, well, we haven't got there yet. We will use things. There will be an easier way to be able to take that, find theta, and then turn around once you got theta, you can find the other side. Okay? So just know that we're going to use trig functions to do that. And we're going to use stuff to evaluate it. So which one do we need? So this is hypotenuse, right? So this one would be adjacent, and that one would be what? Opposite. Yeah. There. Ready? So what do? That would be 11 squared plus 5 squared equals a squared, since it's adjacent, we'll limit a, plus 22 squared. And that would be, what's 121 times 5? Yeah, because you squared 11, you squared, how much? 605? Did y'all get that when you squared 11 squared 5? Yes, equals a squared plus 22 squared should be 444, right? 484, yeah. All right, so subtract 484. What we got? 605 minus 484. 121 equals a squared. Ladies and gentlemen, y'all can see that that is a perfect what? Thank you. So a equals what? 11. Good. So there you go. That's 11, right? So if we do tangent, what would that be? The tangent of theta would be what? Opposite over, so that's 22 over 11, which is what? 2. Okay? You need to simplify your fractions. Yes, you do. Okay? So, make sure that you find that you label hypotenuse if you got it. Because you'll end up doing what I just did and look at it sideways and it mess you up. Okay? Any questions on this one? So will you have to, or may you have to do other stuff to get a side that you need? Yeah. All right. So which other one on that sheet do you want to do? Hold on. Be thinking about that once she's asking a question. Why? Because we're not. The 23. Huh? No, ma'am. No, ma'am. All right. Find the relationships of the sides. Okay? Because you've got to be able to find these relationships in order to be able to do what we're going to do in the upcoming day. Fair enough? All right. Just the relationships of the sides. That's all I want you to do. Hey guys, what would be a really good thing to identify first, right off the bat? Hypotenuse. And then I'd go from there, right? Because you'd be less likely to get in trouble. It's easy to get in trouble and get these switched around, right? So here's hypotenuse. Here's this. So what would this angle be? Adjacent, right? And we need the opposite, right? Now, so sine would be what? Opposite over who? sine of theta equals opposite over hypotenuse. So we have to do Pythagorean theorem, right? C squared equals A squared plus B squared. So that's 4 squared root of 13. 8 squared plus B squared. When you square 4 squared root of 13, you square the 4, then you square the square root of 13, right? Those are two terms, correct? I hate to say two terms. That's a coefficient and a radical, right? So they both have power. So you think about the power to the power rule, that still applies. So 16 times 13 is how much? How much? 208. Thank you. Equals 64 plus B squared. Subtract 64. Yeah. Look at those pretty numbers. What's the square root of 144? That's 12. So our opposite side equals 12. So therefore, our side relationship would be what? 12 over who? Now, here's something to consider. Huh? It equals what?
3 square root of
Over 13. Can I leave my answer like that? Yes or no?
No.
Oh, I can simplify to 12 and 4, right? 3 over square root of 3, right? Yeah, so I can do it. Or square root of 13, right? 3 over the square root of 13, right? Okay, can I leave it as that? I got to move the square root. What do we call that? Miss Smith, what do we call that, huh? It does. Got to actualize in it. Rationalize. There you go. It's crazy. All right, so if we're going to rationalize this, that means you've got to multiply the top and bottom by the square root of 13, right? Because square root of 13 over square root of 13 is what? What's square root of 13 over square root of 13? 1. So we're creating an equivalent, right? So we're just changing. It's like you going in changing clothes, right? You're still you. May look different, right? Like at homecoming, y'all all got dressed up. Y'all getting homecoming. You look different than what you do when you come in here and every day and show up for school. This is going to give you, when we're done, this is going to give you 3 square root of 13 over what? 13. Is that what your calculator gave you? Yes? Did it rationalize for you and everything? Yes? All right. Yeah? Look right there, look. Right there. How'd I get 12? We had to find the opposites, right? We had to find the opposite side by the Pythagorean theorem. Okay. Pick me another one. It is. All you're doing is finding the relationships of the sides, right? We haven't gone to the angles yet, right? Correct? Just find the value, right? Find the value. It didn't say find the angle. It didn't say it. It says find the value. Value is the relationships of the sides, right? Oh. Here. There's a, there's the separation. Is that good? Good. What's your next problem you want to be? 19. Okay. That's great. No, she said 19. She said 19 first.
19 is easy. Y'all were saying nothing but right?
Yeah, you good. Let's go. 19, baby.
We do 13.
Yeah, we do 13 next. Be quick to say, do 13. 19, go. This ought to go pretty quick. There's the hypotenuse, right? So we got to worry about that one, right? So from theta, here is adjacent. Here is what? opposite. Now, tangent of theta is what? Opposite over adjacent, which would be 7 square root of 3 over what? Now, can I simplify that? Do they? Leaves you with what? Yeah. Square root of 3. Question. Okay. Which one do you want to do next?
13.
13. All right, 13. Here we go. All right, 30 seconds for 13. Go. The one thing that I would make sure that I had in front of me when I was working these are all of the trig functions sine relationships, right? All, not 3 of them, all what? 6 of them, right? Seven? No, well, all 7 trig relationships, but no, all 6. Now you done got me saying 7. All 6, and then of course Pythagorean theorem, right? You need a missing side. Now, so what is cotangent? It would be adjacent over opposite. I would write that down. It didn't take but about 3 seconds, but guys, it's going to be very important. Now, first things first, here's hypotenuse, right? Don't make that mistake. Okay, so we need to find the who? The adjacent, right? And then this is opposite. So we need Pythagorean theorem, which is c squared equals a squared plus b squared. 11 squared equals, we'll leave a for adjacent, right? Is that okay? Yes, no, maybe? Yeah. Plus 10 squared, so it's 121 equals a squared plus 100 minus 100. What do we get? 21 equals a squared. So of course, when you take the square root of both sides, it's just, the a is just the square root of 21, right? Okay. Now, could we simplify that radical? We could simplify that radical. Oh, I don't want a decimal. Could I simplify the radical? It's kind of like when I asked the question, did you simplify a fraction? Could you take it in a reduced form? Meaning, could I pull out a perfect square? 4 won't go, 9 won't go, 16 won't go, 25 is above it, I'm done. Because in order to simplify a square root, one of its factors must be a perfect square. Y'all remember prime factorization? Where you done the little tree and you was getting down to prime numbers, 2, 3, 5, all that, right? And you would circle pairs and you pull them out. Y'all remember that? Y'all remember that?
Yes.
Those pairs make perfect squares, right? Yeah? All right, so adjacent is square root of 21, so what would that be? Over 10. All right. Now, guys, you got a sheet of 20 on that, right? How many have we worked? 5, 6, and so we should be okay on that, right? Yay, nay? Yes? Look at your relationships of these sides. That's all we're doing. We're not trying to find an angle. We'll get to angles and stuff like that. So guys, think about this. If you had a right triangle and you didn't know what those angles were, trig helps you to be able to find it. Okay? So from a mathematical standpoint, that was huge. Now, we knew what angle it had to be, right? We could determine that. So that's pretty cool. All right. So Next thing is unit circle. So what I'm going to do is put the unit circle up, and we're going to go through and fill it in. We'll fill in as much information as we can. Okay? So, here we go. Now, so we're going to start out with the easier stuff and then go into the harder on the unit circle. Okay? So, what would this degree be right here? 0 degree. So, let's look at this. If I told you that this was 45 degrees, what do you think this one and the one above it would be? The one below it and the one above it would be? Well, that would be, up here would be what? 90, right?
30 and 60.
30 and what? 30 and 60. Why?
Because
Okay, guys, what did we do yesterday? We looked at a what? 45, 45, 90. We also looked at the 30, 60, what? 90. Okay? All right. So the first blank in here is degrees. Y'all okay with that? The second blank happens to be the radians. So if it's 0 degrees, how many radians is it? 0, good. We said the far right on the x-axis was reference 0, right? We said that. So there's 0. What would 30 degrees be?
pi over 6.
Pi over what?
6.
6. Why not pi over 3? Alright, I said what? If it's a 30, then it has to be, the denominator has to be a 6. If it's a 60, the denominator needs to be a 3, right? They're swapped. Y'all remember that? Alright. So this would be pi over 6. What would the 60 degree be?
Pi over 3.
Pi over what?
3.
3. Yeah. See the little division sign right there? Now, just curious, what's the 90 degree one?
Pi over 2.
It's what?
Pi over 2.
Are you sure?
Yes.
It's pi over 2. There. Now, what would a 45 degree angle be?
Pi over 4.
Pi over 4. Any questions thus far? Now, it's making you hungry. It's like a pizza. Alright. What would the coordinates be? What would the coordinates be, guys, right here?
0, 0, 0.
Right here? No, 0, 0 would be at the origin. What would this be?
0,
1, 0. How did I get that? Because the unit circle is based upon the unit of 1. So its radiuses are all 1s. Okay, yes. Then you got there yet. You'll train right. You'll short circuit the brain yet. We're gonna show you why this comes about, but I just need you to understand the pattern that's going to happen. Just stay with me. Just look at it and go and figure out what I just did. What did I do? Okay, I went 1, 2, 1. And then turn around and went what? 1, 2, 3. Right? Now, listen up. All of the denominators All of the denominators will be 2. All of the denominators, if y'all listen and quit chit-chatting, you'll understand what I'm about to say. All of the denominators are 2. Now, I'm not done yet. So up at right here, we said 1, 2, 3, 1, 2, what? 3. And then we put all the denominators 2, right? So let's go back to numerators. Every one of them get a square root except for 1. Why? Good. Now, do you understand why square root of 1 would only be 1? Everything's going to get a square root in the numerators. Oh, I did, didn't I? I sure did. I just saw it. I know, I just saw it. My hand's quicker than mine. Okay. Questions? So if you think about it, all the numerators got square roots, but square root of 1 is what? 1, right? So that's why 1 did. Are you with me?
Yes.
Okay, good. All the denominators are who? 2. Now. Huh? You okay? Okay, good. Let's look at this one. What would the coordinates up here be? 0, what? 1. Ha 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 ha. All right. Y'all ready? Yes, no, maybe. Okay, let's fill in our degrees. If this is 90, what is this? Think about it. We're doing 30, 45s, and 60s. 30, 45, 60s inside each quadrant. Okay. Shh. Y'all, no. We're doing 30, 45, and 60. So what is 90 plus 30? 120. Right? So this would be 120 degrees. What would be 90 plus 45? How much? 135, and I need to do that in a blue dot. What would this be? 1 what? Y'all agree with that? Yeah. Now, what would the radians be? Yeah, this one's pi, and that wouldn't be 180, and that would be what? -1, 0? Nah. What would this be? What would this one be, guys? All right. So you've got 3 quadrants to fill in, right? If you look online, you can find the unit circle filled out, and when you come here tomorrow, you need to have it completed. Do you understand? So the worksheet front and back plus the unit circle filled in. Do you understand? That's the homework. Go forward.